welcome back to second year organic chemistry. We were studying the chapter on alcohols and phenols. So in the previous video we have discussed about the methods of preparation of the alcohols and also some important physical properties like solubility, boiling point, etc. Now let us go for the chemical properties of alcohols. Chemical properties of alcohols. In these chemical properties of the alcohols, if you consider the structural formula like this, RCH2OH. So there are two types of reactions of the alcohols in which the oxygen-hydrogen bond is cleaved. So cleavage of oxygen-hydrogen bond. In the second set of reactions we have considered, we are having this carbon-oxygen bond. So when this hydrogen alone is involved in the reaction or hydrogen is replaced by some other group, then the oxygen-hydrogen bond is cleaved. In some other reactions carbon-oxygen bond is cleaved so that the whole OH group is replaced by some other groups like halogen atom or various other groups. Now in general we have two types of reactions in which the cleavage of OH bond is involved and the cleavage of carbon-oxygen bond is involved. Now let us explain these reactions by considering ethyl alcohol as an example. Ethyl alcohol as an example. So these are most of the reactions of other alcohols are shown similar to this ethyl alcohol. That's why we will consider this ethyl alcohol as a representative alcohol. Now first let us see the reaction with sodium metal. With sodium metal. If you take an alcohol in a dry test tube and add a small piece of dry sodium metal, then we observe that the brisk reaction takes place with the liberation of the hydrogen gas. So we can write this as C2H5OH plus sodium metal giving rise to C2H5ONA, sodium ethoxide, with the liberation of hydrogen gas. So to balance this reaction we have to take two molecules of this one and two atoms of sodium metal. So that two molecules of sodium ethoxide. Sodium ethoxide. Then the second reaction is esterification reaction. Esterification reaction. This is a general reaction of an alcohol with an acid, a carboxylic acid, giving rise to an ester and water. So in general we can write this as C2H5OH, ethyl alcohol plus acid like acetic acid. In presence of a dehydrating agent like dry HCl or zinc and zinc chloride, etc. So usually this reaction is carried out by HCl. So we will get CH3, COO, C2H5 along with the formation of water. That is OH group of this acid and hydrogen of this alcohol, they are eliminated as a water molecule. Such a reaction of an alcohol with an acid to give rise to an ester. The general class of this type of compounds are ester. So this is ethyl acetate or ethyl ethanoate. That is an ester. Similarly, when you take this ethyl alcohol and reacts with benzoic acid, C6H5OH, COOH, benzoic acid, it will give rise to ethyl benzoate, C6H5, COO, C2H5, along with the formation of water molecule. Any such reaction between an acid and an alcohol in presence of a dehydrating agent like HCl or H2SO4, we can take this concentrated H2SO4, giving rise to an ester. That is called an esterification reaction. Same ester can also be produced by taking another reaction that is called as the acetylation reaction, or in general it is acylation reaction. Acylation reaction. In this case, When this ethyl alcohol reacts with an acid chloride like acyl chloride, CH3COCl, it will give rise to CH3COOC2H5. Here halogen atom from this acid halide and hydrogen atom from this alcohol, they are eliminated as HCl molecule. The product is same as that of esterification reaction. So it is nothing but ethyl acetate. Ethyl acetate along with the formation of HCl. In the same way, we can also carry out the reaction with ethyl alcohol and acetic anhydride, CH3COOCH3. This is called acetic anhydride. Acetic anhydride. The product is same, that is ethyl acetate, CH3COOC2H5, but here acetic acid is another product, CH3COOH. So in these two reactions, the halogen atom or the acetic acid group, they are replaced by this ethoxy group. So we will get ethyl acetate along with the acetic acid. So these two reactions are named as the acylation reactions. If we are using acyl chloride and acetic anhydride, particularly the name is acylation reaction. The next one is reaction with aldehydes. Reaction with aldehydes. For example, when you take this C2H5OH, react with one CH3CHO, acetic anhydride. The reaction is carried out in presence of HCl. It gives rise to CH3CHOC2H5. CH3CH2OC2H5. Sorry, CH3CHOC2H5OH. This is called as hemiacetal. Hemiacetal. Addition of ethyl alcohol molecule to this carbon-oxygen double bond of the acetaldehyde will give rise to this hemiacetal. This hemiacetal CH3CHOOC2H5 reacts with one more molecule of ethyl alcohol to give rise to CH3CHOC2H5 OC2H5. This is called acetal. If both ethoxy groups are attached to this carbon atom, it is called as the acetal. If only one ethoxy group is attached to the carbon carrying the OH group, it is called as the hemiacetal. In a similar way, ketones also undergo addition reaction with ethyl alcohol to give rise to hemiketal and ketal. So generally this reaction is called as the acetal reactions. The next one is with concentrated sulfuric acid. With concentrated H2SO4. There are three important reactions with concentrated H2SO4 depending on the condition. The first one, when we use 1:1 concentrated H2SO4, we can write this as the CH3CH2OH plus H2SO4 giving rise to CH3CH2HSO4 plus water. So one hydrogen from this one and one OH group from this one, they are eliminated as water molecule. So this is a dehydration reaction. HSO4 group will link to this CH2. So it is giving rise to ethyl hydrogen sulfate. 1:1 sulfuric acid and ethyl alcohol at almost room temperature will give rise to ethyl hydrogen sulfate. At about excess of alcohol, excess of ethyl alcohol, at about 140 degrees Celsius, when we take this CH3CH2OH, two molecules, react with concentrated H2SO4, it will give rise to diethyl ether, C2H5 twice O, along with the formation of water molecule. Actually, this is the dehydration reaction between two molecules of ethyl alcohol. CH3CH2OH, CH3CH2OH undergo elimination reaction to give rise to diethyl ether. This reaction is at about 140 degrees Celsius. The next one is when you take this excess of sulfuric acid. Excess of sulfuric acid, that is C. At about 170 degrees Celsius. When you take this ethyl alcohol, CH3CH2OH, react with excess of sulfuric acid at about 170 degrees Celsius. A molecule of water is eliminated within this ethyl alcohol molecule. It gives rise to ethene along with the elimination of water molecule. This is we can call it as intermolecular dehydration. This is intramolecular dehydration. Whatever the water that is produced in these two reactions, it is absorbed by the sulfuric acid to give rise to dilute sulfuric acid. So only elimination of a molecule of water takes place. So this is with respect to the reaction with concentrated sulfuric acid. There are some more reactions that we shall consider in the next video. Thank you.